Hello everybody, it's Monaco again. Welcome to your second homework podcast in your boot camp unit. This podcast is very straightforward. I'm going to go over all the vocabulary terms and definitions that you will be expected to know verbatim for your vocabulary quiz. So you got to know the words of chemistry in order to be successful in chemistry. It's almost like another language. Everybody knows the basics and can communicate ideas, but if you use the right key vocabulary, you really hit the nail on the head and you're golden. So as I go through these words, I'm expecting you to write them down in your unit packet and then afterwards to study and be ready to match this word with that definition when you see it on quiz day. So first things first, volume, the amount of space that matter takes up. Pretty simple. Density. While we do this at the end of our unit, the vocabulary is at the front. It's the amount of matter per unit of volume. The equation is density equals mass divided by volume. Simple, straightforward. Precision. How repeatable is a measurement? So how precise are you? Are you good with your measuring device? Do you get the same number each time? Okay, if I measure the same block of wood, the length of it 10 times, you should get the same number 10 times if you're being precise. Accuracy. How close is your measurement to the acceptable value? Like I said, if you measure that block of wood 10 times, get the same result every time, but then you hand it off to somebody else who uses a different tool, a more accurate one maybe, and they're slightly off, you have a little explaining to do. Why is your number, although consistent, different from what the real number should have been? It's just something we deal with measurement in chemistry. Some basic units, meters. They're about the same in length as a yard, but they're not the same. So you get fundamental unit of length this year is in the metric system. It's a meter, and it's equal to 100 centimeters. The fundamental unit of volume in the metric system is a liter. It's equal to 1,000 milliliters. A gram is the fundamental unit of mass, and a gram is a gram. The gram, liter, and meter are actually all related. I'll tell you that some other time in a different podcast. Mass is, by definition, the amount of matter an object or sample has in it. Okay? It's an indirect measurement of how many atoms and of what type they are. So mass can be weird because mass is independent of gravity. I have the same mass on the Earth and the Moon, even though I might weigh differently. But mass, by definition, is the amount of matter an object has. Matter in itself is the stuff that makes up all things. It occupies volume. It has a size. Matter has mass is another way to think about it. An element is a unique kind of matter. It can't be broken down by a chemical change. So no matter what I do to an element, if it's pure, it'll remain pure unless I react it with another chemical. So if I just hammer on gold, it's not changing gold into something else because it's a unique type of matter. A compound is matter made up of more than one kind of element, and it can be broken down by a chemical change. So when I combine elements of different types, I get compounds. Mixtures, on the other hand, are when I have two or more substances that are put together, but they're not chemically linked. They can be separated by a physical change. So this is literally like salt mixed with sand. Okay, they're not reacting with each other. They are independently salt and sand still, but they're mixed quite well, and you have to separate them by a physical change. The types of mixtures are heterogeneous, so this is one that does not look the same throughout, or it will settle upon sitting. So if you mix sand with water, you might shake it up for a second, it looks all the same, but then the sand falls to the bottom and the water stays on top. That would be a heterogeneous type of mixture. It's a mixture because you can see the two different types of matter in there, and it's heterogeneous because you know that they separate. Now, homogeneous, it's a mixture that is visually the same throughout. It doesn't settle out upon sitting, and it'd be like sugar water. You know, you take your sugar and you add it to the water, and you know it's a mixture, but no matter how long that glass of sugar water sits on the table, assuming nothing evaporates, it will look the same. So you can't see it settle out. So those can be tricky to identify sometimes. When I say pure substance, I'm talking about any type of matter that is composed of one element or a compound. Okay? There's some generalizations. Sometimes Mixtures are considered pure, but that's not really how we're going to go at it from this level. Okay? When I say pure substance, I'm talking about matter made of one element or one compound, no mixture. A particle diagram is a picture that represents the matter in a given sample. They're going to be little boxes with spheres that may be different colors or sizes or shapes in there to show you, imagine in your imagination, that you've got atoms in there. Here we go with some separation techniques. First thing, chromatography. We can only see this briefly on paper. It separates a solute from a solvent based on particle size and polarity. This is a very complex technique. We don't do much of it because it's easy to mess up. Filtration, on the other hand, is a very simple technique that we use to separate mixtures based upon solubility. We can do this, we will do this repeatedly. Distillation. That's another separation technique that I use to make distilled water around here. It separates liquids based on different boiling points, okay? I can do that. I can do that in lab. I can show you that. I can demonstrate it. It's very fun and interesting. Percent error is a calculation that'll tell us how far away a measured value is from an accepted value. If you measured my height to be 5 foot 10 inches, that's great. What would the doctor measure my height to be? 5 foot 10 and a quarter. How close was your measurement compared to the doctor's measurement? What percent error did you have? And that's all, folks. Those are all 20 of your vocabulary terms for this unit. Make sure you wrote down the notes, and then you study them so that you can be successful on our vocabulary quiz. Thanks for watching.